Hello, my name is Barbara and I would like to show you today how to use the template editor to generate template groups. In this example, we would like to detect individual palm trees. So I open the template editor window and generate a new template. We call it palm trees. I also select a folder where my template should be stored. And I simply want it to be stored right next to the images folder in a template folder. Now we are ready to select samples. I'm going to try to click into the center of a palm tree. As you can see, we also need to adjust the template size. And now that looks good. So we select a few more. And in this example, you probably realize that just generating a mean template will not be very useful because the palm trees are rotated at random orientations and the characteristic leaves will just average out. But let's see what we get. I'm going to just generate a template for layer 1, and you see that the correlation coefficient is not very high. Here in layer 2 it is a bit better. Layer 3 and layer 4 we just have nothing, so it has a very good correlation, but we will not find anything with this template. So now we have this group size parameter, and what it means is the algorithm is trying to find subgroups in our samples, and for each subgroup generate a template. So when we do this here, you can see that the correlation coefficient is much improved from about 40% to almost 60%. And when we try to interpret the image, we can see that the palm trees are simply rotated versions of each other. Now let's test this template. So we said the optimal template is in layer 2, group size 3, from those that we have generated so far. And we need to select our test region, and I simply want to test it on the whole image, which is 1200 by 1200 pixels. Now we need to select a threshold, and typically what I start with is something like the value I get for the mean correlation. So let's start 0.6 and execute the test. So we see that we get a number of good trees here. Maybe we want to have a few more, so we can simply lower the threshold. Okay, they all look good. And now we see that we have many more samples for our trees, and we simply regenerate the template. And pay attention whether it becomes a bit cleaned up. Yeah, now it looks already nicer. And now we want to decide, maybe we can zoom out a bit here, what the optimal template group size is. So for group size 3 we have 0.66 correlation coefficient. Let's try group size 4. Will we benefit if we have more groups? This actually reduced the correlation coefficient a little bit, so having a group of 4 is not worthwhile here, and we also see that this doesn't really, it's not easy to interpret what that group would reflect. What happens if we go to group size 2? Here the correlation coefficient is 0.58 or 0.59 if you round it. So we can see that there is still quite an improvement from group size 2 to group size 3. So in this case we would select group size 3 as our optimal template group size. I should say that finding the optimal group is always a little bit a mixture of looking at the values and using your intuition. It's not a real science. So now let's test this template again. And we want to find now as many trees as we can. Actually, let's just repeat the test and see how the update of the template improved our results. You can see that it finds now many more trees, and they all look good. And now for once I would like to repeat the test with a really low threshold to find as many trees as possible. When we execute tests with a low threshold, the algorithm can sometimes take quite some time. So if you realize that maybe you generated a test that takes too much time for you right now, you can always click on the cancel button and then adjust the threshold and rerun the test. But you should also consider that all the work that goes into generating a template really pays off afterwards when you can use a template and get better results. Here you can also see an indicator of the time that it takes, and we'll simply have a little bit of patience. Alright, here we are. So the trees that you see here all look good. This one maybe. Yeah, no, that looks also good. This one looks too much off center. This one's okay. Let's see here. It's okay. They actually all look okay. Okay, so now we can look back. We want to see how many were actually picked out. A good trick is to go back to select samples and to reduce the template size. So use here 15, because now you can easily see where your samples are. And we can see that actually I can't now find a single tree that was not picked out. So we are quite happy with the template now, but let's update it one more time from the newly found samples, because it will probably clean up the template even further. Oops. I forgot to adjust the group size back. Okay. Now that looks good. We can zoom out even more and generate the template. I can also show you where you'll find your templates in the end. We had selected this templates folder, so here we can see. Here you now see all the group and layer combinations that we generated. We generated a template for layer 1, 2, 3 and 4 for group size 0. And for layer 2 we generated also group size 2, 3 and 4. So if I click in here, you'll see the templates for layer 2. Because these are 32-bit float layers, we don't see a nice representation in the Windows preview. We can open the image with Earthen View. Then you see what the template looks like. So now the algorithm has finished, and you see that the templates have cleaned up even further. Oh, now I clicked the layer again. I want to look at the final result. And if we browse now through these 3 templates, we can clearly see how they reflect rotated versions of each other. Okay, so I have shown you how to use the template editor to generate template groups, and also how to decide for the optimal group size. I would like to thank you very much for your attention.